The first thing we need to do is really decide what is going to stress a plant. So a plant is going to be exposed to a number of different stresses, and those stresses are going to be defined as really any unfavorable condition that will affect or block a plant's metabolism, growth, or development. And it should be no surprise to anyone on this call that plants are exposed to a number of different stresses. We can kind of loosely classify those as biotic or abiotic, where your biotic stresses are going to be your living stresses. So these are things like disease, insects, animal feeding, weeds popping up, sort of the things that have life associated with them. And then there's the second class of stresses, which are called abiotic stresses, and these are the non-living stresses. So these are things like water stress, which is a big focus of this talk, as well as salinity, nutrient availability, as well as physiological stresses like injury or your soil structure. If we think about abiotic stresses and we look at the graph here, we can see that upwards of 75% of losses are actually caused by abiotic stresses. So we could have all of the diseases in the world, but ultimately, at the end of the day, your abiotic stress is going to have a larger impact on your yield. So these are showing results for row crops, but as I'm sure you're aware, this is really no different for specialty crops, and in this particular talk, the grape crop. So if we consider the headlines we've seen in the last 10 years, and thank you to Ismail for the very thorough introduction on climate change and kind of the stresses that we're dealing with. Grapes are a tough crop to grow. There's really no kind of way around that. In the last 10 years, and I tried to cherry pick headlines here, of the last 10 years, we can see that the climate and the weather has been an issue for not only the United States and Canada, but Europe as well. In fact, France lost something like 2 billion euros in 2021 due to a spring frost. Canada is in a very similar, albeit smaller, problem this year in the Okanagan Valley in British Columbia, which is on the West Coast. Our growing season hasn't been great, and we've lost quite a bit of crop. And I think in parts of the US, we are in a very similar scenario. So these late winter freezes and spring frosts are going to continue to threaten the ability of growers to generate a profitable crop. In order to kind of understand how to protect yourself against frost and freezing, we need to make some baseline definitions so that we're all talking about the same thing here. And what we tend to do is use the words frost and freeze interchangeably. Scientifically, they have different definitions, but you'll hear them kind of thrown around or largely grouped into things like cold stress, cold damage, frost damage, freezing damage, pretty much cold weather that is causing damage. But scientifically speaking, frost is just when the air temperature actually drops below 0 Celsius or 32 Fahrenheit, whereas freezing is actually internal ice formation. And the important way to think about this is that a frost event can be a freeze event if you get ice forming within your plant tissues. These freeze events can actually occur in two ways. You either get an intercellular freeze event or you get an intracellular freeze event, meaning either between your cells or within your cells, respectively. We really care the most about intercellular freezing, so that freezing that occurs between your cells. And that's actually what is believed to cause injury during spring frost. So when this happens, what you'll actually get is a vapor pressure deficit being established between the inside and the outside of your cell, and it'll cause water to actually move out of your cell. As soon as the water is moving out of your cell, we now have a deficit of water within the cell, and it allows water to really deposit on the ice crystals that are between your cells or in the intercellular space. Because we have water moving out of our cells, the cells are becoming dehydrated. And when they become dehydrated, they lose their turgor or their nice kind of structured shape. So we actually look at frost and freezing events, well, specifically freezing events, as a dehydration, which means we have to more or less regulate how the water is flowing within these cells. During the spring, grapevines are going to be particularly sensitive to freezing temperatures. There's a lot of new tissue, there's opening buds, there's young shoots. We saw the overwintering process and how cold hardiness sort of develops along the season. And unfortunately, during the springtime, and you have this tissue starting to wake up, we are kind of at a low for cold hardiness for the season. And at bud break, we have a lot of growing organs. So, every frost isn't going to kill the plant. So it would stand to reason that certain growth stages are going to be more susceptible to frost and freezing. And those growth stages tend to be when you have growing organs because of the high water content of those organs. So really the thought process should be growing organs mean a high water content. A high water content, unfortunately, means that they're susceptible to that water moving out of the cells, depositing between your cells, and getting ice formation. And if it wasn't enough just to have to deal with the water movement, there is also multiple different types of frost we have to contend with. So there is two types of frost and two types of freeze events. They do differ in frequency and occurrence, as well as the cause of them. Those are going to be classified as either a radiation freeze or an advection freeze. So radiation freeze, which is probably the most common one that we deal with, is also the easiest to protect against. This is what happens when the heat moves from your soil and your plants back into the environment. So the plants and the soil tend to be a bit warmer than the cool air, and it'll actually radiate out the heat and back into the environment. So it's a loss from the plant to the environment. The other type of freeze, which unfortunately is a bit harder to control, is an advection freeze. And in this case, heat is actually stripped away from the plant or your soil by horizontal movement of cold air. So this is what happens when you get a particularly large cold front moving into the region. It's accompanied by really low day and night temperatures, high winds, and it'll really bring that cold air from the upper and lower areas of the atmosphere and mix them together and drag them across your crop. Unfortunately, we do struggle a bit to control these advection freeze events. They're not easy to control. And typically, most of the protection mechanisms we have to mitigate frost damage are rather ineffective against things like advection freezes. So a common example of this is a wind machine. A wind machine is great for radiation freezes, but when you have those really high winds coming in, bringing the cold air, the wind machine is just really no match for Mother Nature. So we need a strategy. This isn't a simple thing to think about. This can be quite complex, but overall, the goal is the same. The goal for any good frost strategy is going to be to keep plant tissues above critical temperatures. And what I mean by critical temperatures is the temperature at which your tissue will die. So we want to keep it above this temperature, keep the plants out of sort of the danger zone by using a combination of active and passive methods. So the way we can accomplish keeping the plant tissues above critical temperatures is really twofold. We either need to avoid the frost injury altogether by reducing the frost risk, or we need to protect the plants through temperature modification. So, sounds simple enough, but is it feasible? And that's a question we tend to get a lot in the field. Is this something that makes sense? It's a balancing act. There's really no way around that at all. Yeah, so in theory, you can protect a plant, any plant, if you have unlimited resources, funds, land, and ability. Unfortunately, it's not always economically feasible to do so. So it's not going to be economically feasible to put tunnels over an entire vineyard and set up a greenhouse system. And we know that. So the strategies that we propose must be economically sound. And when we think about the economics behind this, we actually have to consider not just the grapevine, but we have to consider the expenses, so your labor costs, your management practices, what's going to happen if you lose your crop for the year. Is it going to completely bankrupt your organization? Is it going to just be a drop in the bucket? You know, there's a lot of different things to consider. You also want to consider the overall health of your plants. The practices that you choose to implement, maybe it's a late prune, how is that going to help or hurt your plants? Do you need to tie things up? Things like that. The good news is that with a little bit of initial planning, you can save some time and money, but you really should be thinking about what can be implemented today. So how can you set yourself up for the best chance of success for this growing season? There's really two types of protection strategies that we talk about for frost protection. And those are going to be passive or active. So the first type is a passive frost protection strategy. Your passive frost protection strategies are going to be indirect measures, and they will actually work to decrease the probability and the severity of your frosts or freezes. So they will make plants less susceptible to cold injury, and they are typically some are implemented before and some are implemented after, but I would argue that the protection strategies implemented before vineyard establishment are going to be the ones that have the biggest return on investment. So those that can be kind of considered before establishment are your site selection and your variety selection. We'll talk more in depth about site and variety in the coming slides. But these are things you definitely want to consider when you are setting up a new crop, perhaps pulling out old vines and putting in new vines, or if you're looking to expand your operations into a new vineyard. Post-establishment, we're really talking about cultural practices. So these could be like your trellising system, your training system, soil management, nutrient inputs, pruning practices, adding chemicals, middle row management, disking, your cover crop. There's kind of a lot of different things that can happen once the crop is already in. But we do consider most of these to be passive protection strategies. The second type of a protection strategy for frost protection is going to be your active frost protection strategies. These are going to kind of be, I don't want to call them your emergency protection strategies, but these are strategies that if you don't have a frost event coming, you are likely not going to necessarily implement every one of these. But I do encourage you to develop a balance of both active and passive to really have the best chance at success for the year. So these direct frost protection methods will modify your vineyard climate and inhibit ice formation. And if we remember, I know I'm going a little bit quickly here, but if we remember back a few slides, it's really that ice formation that causes problems. The formation of ice drives the dehydration event, which will inevitably cause the damage on your plants. So these direct frost protection methods depend on the characteristic of your frost. So is it going to be a radiative frost event, freeze event, or is it going to be ejective? Are we getting cold air coming through, or is it really just about losing heat to the environment? So active frost protection strategies or active frost protection measures really work to either conserve, add, or move heat. So those three kind of classifiers can be thought about in terms of, can I heat my air? Can I conserve the heat that's already present? Or can I move warm air into my vineyard? And the way we do this is either with heaters, which are point applications, The wind machines, which we've already kind of mentioned, aren't great for ejective freezes. Over vine irrigation. There's also, in some areas, there's under vine irrigation with warm water. But then there's also things like plant-based dispersions. And we will talk kind of more about that towards the end of the slides here. So I'm going to go through considerations for developing your frost strategy. I do apologize, I went through the introduction material pretty quickly, but I do think that this is kind of the most important topic to spend time on so that I'm just being respectful of everyone's time. So when we were developing this presentation, we had initially titled this slide Current Practices. And my technical sales rep thought it was hilarious to put kind of an old looking medieval castle European vineyard here. So I thought it would be funny to keep it in, but we can see that, this particular vineyard, although very European in nature and kind of old school looking, has a very healthy looking crop. So we would have to assume that they are actually implementing some of these strategies. So when we're talking about developing a strategy, as I mentioned in the introduction, there's going to be 7 sort of categories that we want to talk through. And the first thing that we like to recommend you do is you monitor your weather. I think it's no secret that weather can kind of change rather quickly, especially in Michigan. We get lake effect. Some areas are protected, some are not protected. Sometimes we get Arctic air moving in from the west and the mountains. But investing in a reliable frost alarm can save you time and money. And this doesn't replace going out into the field and checking your buds, as we heard already, but this can give you that added level of protection, peace of mind, to just be alerted if an unexpected cold front has moved into the area. We know that critical temperatures are what we have to be sort of aware of. And unfortunately, shoots, buds, and leaves all have different critical temperatures within a plant, and it'll also depend which developmental stage they're at. So temperatures as high as 30 Fahrenheit or as low as 30 Fahrenheit can be a problem. And unfortunately, in 2024, we've had a lot of accumulated degree days where we are getting some early development. So moving forward for this year, weather monitoring is going to be critical to kind of fighting the frost. In terms of cultural measures, as I mentioned, these are more of the passive measures. Really, the most important thing here is air drainage. So air drainage through mid-slope locations with minimal obstacles are going to kind of work in your favor. Cold air will tend to settle in your low-lying areas, so you want to have as few obstacles within the airflow in order for air to actually drain away so that you don't get these pockets of cold air kind of persisting for long periods of time. Windbreaks can also be advantageous when you have advective frost conditions. Unfortunately, because they work well for advective frost, they tend to create problems in radiative frost. But if, we think about this kind of as a balancing act, once again, we do have to have strategies for advective frosts, and windbreaks can be a good option. The next one is cover crops. So soil that has cover crops can actually contribute about 0.6 Celsius of heat as long as they are kept mowed and fairly short. So you want your cover crop to be low and away from your vine or your developing fruit so that the cold air will stick low to the ground with the cover crop rather than up towards your fruit. And the last one is really a darker soil surface. So when you have a darker soiled surface, that's either bare, tilled, and irrigated, it will actually absorb more heat during the day and then release it back at night, kind of in that radiative manner. So it can also provide anywhere from like zero point 0.6 to 1 degree Celsius of protection, but only if you're not using sprinklers. So this is kind of a measure when you don't maybe want to turn on the water. Another preventive measure that we consider, and these are the before vineyard establishment measures, are cultivar optimization and site selection. So cultivar optimization is really about choosing what's best for your region. So you want to prioritize cultivars that are known for either a later bud break or a bit more cold hardy, especially in areas that are going to be more susceptible to frost. You want to be looking for frost tolerant hybrids or rootstocks, and only plant frost susceptible cultivars when there's adequate protection, proper air, and water drainage. Yeah, so it's going to kind of differ based on what you choose to plant. And as Isabel introduced, we are going to have different levels of cold hardiness with different cultivars. So choosing those that are a bit more cold hardy is going to work in your favor. I'm not going to spend any time on site selection because I assume most have their vineyards already set up and nobody's really looking to move their operation. But essentially, those that were talked about in the cultural measures, so having good drainage, having good airflow, wind breaks, things like that, those are going to be the best things when you're establishing a new site. Obviously, you have to consider things like soil fertility as well. But having that mid slope with good airflow is going to really set you up for success. For physical considerations and implements, you want to put your buds higher on the trellis. So a frost risk will actually decrease by approximately 2/3 of a degree for every 4 inches of height above the soil level. So the higher you can actually get them away from the soil, the more protected they're going to be. You also want to delay pruning. So again, Ismail gave a fantastic introduction of adjusting your pruning strategy. So when you delay your pruning, you can actually avoid accelerating your bud break. And if you delay it further and do a double pruning, you can further delay your bud break. So in a year where we're really trying to protect those soft tissues from the cold air, this can be a great strategy to implement to make sure that we're not moving things too quickly and we're kind of out of that frost danger zone. Another physical consideration, like I said, if you had unlimited time, money, and resources, you could consider is covering your vineyard with a woven fabric. It's very expensive, so this is anywhere from like $8,000 to $12,000 an acre. So for any Europeans on the call, this works out to be close to $20,000 to $30,000 per hectare. It can help with heat conservation, but again, this really isn't economically feasible for the average vineyard. The other physical consideration that we want to be aware of is just being aware of obstacles. And these could be kind of fixed obstacles like a barn, or it could be something that we don't necessarily think of, like a stacks of bins. You want to make sure you're practicing good weed management, keeping those weeds low, try and avoid fences or large buildings that can actually hold cold air in your vineyard. And just being aware that you may get pooling in some of the uphill areas. The mechanical controls, which are more of the active type of protections, are going to be wind machines, over vine irrigation, and heaters. These are the 3 most common that are used. Wind machines will blend warmer air with cooler air near the vines. So in these frost events, you will tend to get the settling of cold air under the warm air in the radiative freezes, which is called an inversion. So by using a wind machine, it will actually blend that warmer air with the cooler air near the vines, and raise temperatures anywhere from like 1 to 3 Fahrenheit. So it's about lowering or improving, I guess, the temperature surrounding your sensitive tissues. Over vine irrigation is also one that has to be kind of planned ahead of time. So you need to have the right setup, you need to have a sprinkler system or an irrigation system and access to enough water to really make this effective. And in this control, what's happening is you're actually creating and insulating a layer of ice on your vines, and heat will actually be released as ice starts to form, insulating the vines from that really cold air and prevent it from getting the freezing or the ice formation within their cells. Heaters are probably the least effective of the three listed here. These are really point applications of heat. So yeah, it depends on the type of heater. And I know that burning barrels has been used pretty frequently in the past for heating vineyards, but it's really a point application. And this type of heat introduction is really affected by wind. So just something to consider when you're considering the economics of protecting your crop. In terms of chemical measures, these are kind of few and far between. There are about 5 different chemical measures you could consider to use. And unfortunately, I can't speak to the efficacy of each of these, but these are kind of commonly used, and some people swear by them. Some people think they're snake oil. It's really just about what works for you and what you've found success with. So the first one is a vegetable-based oil, and it's been found to delay bud break anywhere from 2 to 20 days. So this can be incredibly helpful. Or there is KDL, which is produced by Agro-K, which is a potassium dextrolac. This is really one that needs to be applied at least 36 hours before a frost, followed by a repeat application 36 hours after the frost event to be effective. Vapor Guard from Miller is more of a terpene polymer. So this will actually form a microscopic film over the leaf and plant surface, and it works to actually reduce the loss of water. So you don't necessarily get that vapor deficit being established or not established as quickly. Therefore, this will improve your cold tolerance. Then there is a class of compounds called ethylene inhibitor sprays. Unfortunately, they're not currently registered for grapes, but something to keep an eye on for the future. So the most common one is Ethrol from Bayer. And I was told the active is Ethifon. So what it'll do is it'll just delay bud break on certain crops, but it is a really precision timed application. So you have to kind of be on it immediately and at the exact right developmental stage to catch that. The last type of chemical measure I want to mention is copper sprays. So copper sprays, like badge, will really work to eliminate ice nucleating bacteria. There's limited efficacy data on this, but I do believe that people in cold growing regions have had a bit of success with this. So just another tool kind of in your toolbox to really think about when you are developing your cold tolerance strategy. And finally, the last type of tool I want to introduce is a botanical or a natural tool. So there are 3 that currently exist on the market that are utilized. And the first one is going to be called Cellurods from a company called Celluforce. So these are really sodium neutralized cellulose nanocrystals, and they will actually coat the plant to prevent ice nucleation. So you spray it directly onto the buds to reduce mortality rates during your freezing events. And the thought is that if ice can't form, you can't get that dehydration effect from the intracellular freezing. Another one to consider is a product called Trainer from Hello Nature. It's a vegetal protein hydrolysate. and it works to reduce plant stress by improving nutrient uptake. There's claims of improved root development and plant growth, but really it's acting to get the plant through those periods of stress. And last but not least is Lelstim Osmo from Lalamon Plant Care, which I'll spend a bit of time kind of describing here. But it is a glycine betaine based product. It's 97% glycine betaine, and it will actually stabilize membranes and cellular proteins, acting as an osmoprotectant. So what this means is that it will facilitate water uptake and retention, and then act as an osmoprotectant. So it's really working to adjust the osmotic balance, so the flow in and out of water within a cell. So we've found through various avenues of research that this can increase the temperature tolerance from anywhere 1 to 6 Fahrenheit, depending on the crop. So what is glycine betaine? I said it was present in Lelstim Osmo, but glycine betaine itself is actually an essential amino acid. And this amino acid will actually penetrate the plant tissues to help stabilize membranes and cellular proteins. So it'll facilitate that water uptake, it'll act as an osmoprotectant, and it'll regulate the flow of water in and out of their cells. It's also a great source of nitrogen because it is an amino acid. It'll help to provide energy for the plant, and it's a naturally found substance within plants. So this is very natural. It's produced by most plants for stress mitigation, and it's really about just putting a concentrated form through. So again, it helps with stress control and helps plants continue their natural growing cycle rather than shutting down. So just a reminder, plants are going to be subjected to lots of stresses, including water stress. And frost and freeze damage is actually caused by dehydration, which is the water moving out of the cell. So the thought is that if we can actually control the water and regulate the water moving in and out, then you should be able to protect your plants from frost and freeze damage. So water movement is going to be incredibly important, but what does it really look like? So in a perfect world, we have, sunshine, nutrients, water, carbon dioxide, and your cells are performing as normal. So they're getting water, carbon dioxide, and light in. They are putting sugar, proteins, and oxygen out. So they're conducting photosynthesis, there's lack of cracking, we get good color and uniformity, higher Brix index in the fruit, and you get a healthier, more disease-resistant plants leading to higher yields and therefore higher profitability. Unfortunately, we don't live in the perfect world, we live in reality, and really we deal with two types of scenarios. So we either deal with hypertonic cells or hypotonic cells, so too much or too little water. And what will actually happen is if plants are exposed to too much water, you will get it moving into your cells. And if they're exposed to too little water, it will actually dehydrate your cells and water will move out. So, in abiotic stress conditions, you either are going to get, on the left here, the closure of the stomata, photosynthesis stopping, protein synthesis stopping, microcracking happening, and pathogens coming in. Or on the other kind of scenario where water flows in, you get extreme cell wall tension, more microcracking, more disruption of photosynthesis and protein synthesis, and just really an unhappy cell overall. What glycine betaine does is it actually will help to regulate the flow in and out of water so that we don't have these extreme swings where our stomata are closing or tons of water is flowing in and you're getting these hypo and hypertonic cells. So in these scenarios, glycine betaine will actually help to regulate the amount of water and the speed at which the water will actually flow in and out of your cells, and therefore adjusting your osmotic balance. And by doing so, we kind of try and exist more within that happy medium, where we don't have dehydrated cells like we do on the left of the reality diagram, or the really overinflated cells like we do on the right, but rather we have that nice healthy balance where, yes, stress is happening, but we still have normal cellular respiration and normal cellular functions. So I mentioned the product is called Lelstim Osmo. So it is 97% glycine betaine, which is the actual molecule or compound that is responsible for this regulation and this water sort of regulative effect. So it comes as a soluble powder. We apply it as a foliar spray. There'll be some application instructions towards the end here, but it's available in 5 or 55-pound bags, and you get 3 years of shelf life, which is great. It's OMRI listed, and it's suitable for use in organic farming in accordance with EcoCert as well, if that is important for you. Glycine betaine contained within Lelstim Osmo is natural. It is derived directly from sugar beets, so it has 100% plant origin. And then it's separated, purified, and crystallized to give the 97% concentration. It's compatible with most tank mixes. The only one I would advise to pay attention to is copper. So things that tend to cause phytotoxicity on their own, we want to be careful, because as we change the osmotic regulation of our plants, it will actually just kind of supercharge those effects. So if we know copper may cause phytotoxicity, we want to just be careful of mixing it with Lelstim Osmo. And then again, it is an effective osmoprotectant, facilitating water uptake, adjusting your osmotic balance, improving photosynthesis, providing nitrogen sources, and it'll actually help with protection during your adverse environmental conditions like heat, cold, frost, drought, and salinity. So again, we have some advantages here. The one I want to draw your attention to is that it improves water uptake. So if we know frost and freeze damage is a dehydrative sort of stress, having a better water uptake and having a regulated water uptake is really going to help with your crop resilience. It'll also translocate within 24 to 48 hours and persist for several weeks. So reapplication intervals are, I believe, 1 to 3 weeks for frost protection, but you do get a fair bit of coverage. It'll also help minimize your yield losses. We tend to recommend this for a variety of different crops. It's really a great hardy product. So for this group, it's definitely registered for use on grapes, and it has lots of supporting research from the company that I'm happy to discuss at a later time on grapes, especially with things like hydric stress. And as I mentioned, just some application rates and tips. Really, you want to apply this when conditions are favorable. So we're talking good humidity and without rain falling immediately after. So you want it to get on your foliage and have some time to persist there, so you get that absorption and translocation. And as mentioned, you can mix it, but avoid herbicides and just be careful with copper. So for frost, drought, heat, and salt stress, the application rates are 1/2 a pound to 2 pounds an acre in a volume of 20 to 100 gallons, spraying once every 1 to 4 weeks. So from bud break through stress periods. If you're interested in learning more, you can check out our whole product portfolio at the website that'll be provided at the end, but we do offer a variety of biofungicides, bioinsecticides, plant growth promoting rhizobacteria, as well as the Lelstim Osmo product. So just something to think about as you progress through your growing season. And just to kind of wrap it up, once again, I want to thank everyone for your time. But the last words I want to leave you with are that a good frost protection program is not a one-size-fits-all solution. This has to be tailored to your individual growing conditions, and it will either work to add, conserve, or move heat. You can use chemical, physical, or botanical measures to help mitigate your frost damage for 2024 in the future. But multiple methods, products, applications, cover crops, lots of different protection strategies might be necessary. And just to mention that Lulstim Osmo will represent a new tool in the fight against climate variability, but it's not your only tool. We recommend this be incorporated, but it's not something that is going to be solve all of the problems. With that, I'll leave you our contact information, and I encourage you to direct all of your really tough questions to Ryan because he's been silent for this entire presentation. So thank you.